Question number 5 is another tangent question. Well, they all are, right? Because that's the guided notes. And it says that RB, so this ray RB, is tangent to circle O. Again, the reason that matters is because tangent lines create right angles with radii at the point of tangency. We need to find the value of x, so that's this indicated angle here. And there's a couple ways to do it. One is that we know this triangle has a sum of 180 degrees. So we could add the 33 and the 90, which is 123. So if these have a sum of 123, we could subtract that from 180 to get this angle, but then we'd have to subtract it from 180 again to get this angle. So instead, I'm going to use the exterior angle theorem of triangles, which says that this angle here is equal to the sum of these two angles inside the triangle that don't make a line with this given angle. So basically that means this plus this is 180, this plus this is 180, therefore this plus this is this. So 123 degrees is my given angle measure. Okay, so for this guy it says, let's see, plot points W, X, Y, and Z so that XY is a radius, XZ is a diameter, and arc WZ is 60 degrees. Okay, so the most useful to me right now is that XZ is a diameter. So I'm going to draw a diameter first and make that X and make that Z. Doesn't matter where they go. I'm going to put them there. Because XY is a radius and X is already here, that means that Y has to be the center of the circle. From here, I need to also plot a W such that the arc made by WZ is 60 degrees. It doesn't have to be perfect, but it should be reasonable. 60 degrees is less than 90, and because one end is here, I'm either going to draw a point here or draw a point here. I'm going to choose to do it here and call that W, and then if I draw this line, this central angle would be 60 degrees, so that this corresponding arc measure is 60 degrees. Number 7 might be one of the trickier ones on this diagram because you have to look at a few things. You have to see that here we have circle K, that's the center. The radius is 5 inches. I'm actually going to label that in my diagram right now. It says if ID is tangent to circle K. That means that if this is tangent to circle K, that means that it forms a 90-degree radius with, a 90-degree angle with its radius at the point of tangency at point I. That's useful because if this is a radius of 5, this is also a radius of 5. That's important. We need to find the length of ID, so we need to find this distance here, okay? So I don't know what that is, but I do know that this is a special right triangle because I see that 60 degrees there. So I'm actually going to kind of channel what I remember about 30, 60, 90 special right triangles, which is that the short leg and the hypotenuse have a ratio of 1 to 2. And then the long leg, which is opposite the 60, has a ratio of 1 to radical 3 with the short leg. So in this case, the part that I have is the short leg. It's opposite the 30 degrees, because if that's 90 and that's 60, that must be 30. So if this is 5, then this is 10, and this is 5 radical 3. So the part that I'm looking for is the long leg. It's opposite the 60, and so the answer here is that it is 5 radical 3 inches.